Assalamualaikum, my name is Farhan. I'm from Group 5 and our topic is Preemptive Scheduling, SRT and Round Robins. So this is our team members, Muhammad Shafiq, me, Muhammad Farhan, Taufik and Aizat. Introduction to CPU Scheduling. First, what is CPU Scheduling? It is the process of determining which process gets the CPU and for how long. It manages how multiple processes share the CPU resources. Why is CPU scheduling important? It is because it will maximize CPU utilization, means keep the CPU busy. And it minimizes response times, which ensure that quicker user interactions. It also minimizes turnaround times, which is total times to complete a single process, and ensure fairness among competing processes. And then we break down to preemptive and non-preemptive scheduling. For preemptive, CPU can be taken away from a process if a higher priority process arrives or its time slices expires. For non-preemptive, once CPU is allocated, process runs to completion or blocks. Then we go to our main topic, preemptive scheduling. So what is preemptive scheduling? It is a strategy where the operating system can interrupt a current running process to give the CPU to another one. Meaning, the process will run simultaneously and will get the CPU fairly. This is crucial for modern computers, allowing them to be responsive and handle multiple applications at once, ensuring no single task can monopolize the system resources. So the benefit is the responsiveness. It will ensure the interactive application remain fluid, meaning you can open many applications in your laptops or desktop. Fairness, preventing any single process from monopolizing the CPU, such as the Chrome browser cannot utilize all the CPU to itself. So if you open the YouTube or whatsoever, it will will give the CPU fairly, and handles dynamic environment which adapts to new process arrival and changing priorities. When you open another applications or software, it won't disturb the current running processes.
My name is Muhammad Aiza bin Abdul Rashid. I want to explain about shortest remaining time SRT. What is shortest remaining time SRT? Shortest remaining time or SRT is a preemptive CPU scheduling algorithm. It always selects the process with the shortest remaining execution time. If a new process arrives and it is shorter than the one running, the CPU switches immediately. This allows faster processes to complete quickly but might delay longer one. SRT has the advantage of minimizing average waiting time. It's very effective when the system has a mix of short and long tasks, but there are downside. It may cause starvation. Longer processes could keep getting skipper. Also, SRT requires knowing or estimating the burst time, which is always possible in real system, and too many context switches can reduce CPU efficiency. To help us and others understand how SRT and round robin work, we built a visual simulation using P5.js. It's allowed to user to simulate CPU scheduling step by step. You can see when preemption happen, how process are selected, and how the CPU switches tasks in real time. This this really helped turn abstract theory into something more practical and visual.
Hi, my name is Taufik. In this video, I will be demonstrating the shortest remaining time first or SRTF scheduling algorithm using this interactive simulation built with p5.js. So SRTF is a preemptive scheduling algorithm which always runs the process with shortest remaining burst time. If a shorter job arrives while another process is running, the CPU will switch to that new process. Let's click the Start Simulation button. So the initial process list and execution table are now displayed below. So we can use the Next Step button to go through the simulation one time unit at a time. At time 0, the P1 has arrived, so the CPU begins executing P1 and its burst time is 8. So at time 1, the P2 arrived with a burst time of 4. Since P2 remaining time is less than P1, the CPU preempt P1 and switch to P2. So at time 2, now P3 arrive with burst time of 2. Again, 2 is less than P2 remaining time, which is 3. So the CPU switch to P3. At time 3, P4 arrive with a burst time of 1. At this point, P3 also has only 1 unit of time left. So because both P3 and P4 have the same remaining time, but P3 have arrived earlier, the CPU continues with P3. So at time 4, P3 finish execution. Now P1, now P4 with the shortest remaining time of 1 start and completes in the next unit. Okay, at time 5, between P1 and P2, P2 has a shorter remaining time of 3. So the CPU resume P2 until it finish at time 8. So only P1 is left with 7 unit of time remaining. It resume and runs until it finish at a time 15. So the timeline above shows how the CPU switch between process based on their remaining times. You can clearly see the preemption in action as shorter job arrive. Here is the final execution table. Each process shows its remaining burst time and the finish time of each process. All process has been successfully completed. So the SRTF algorithm minimize average waiting time but may cause starvation for longer process if many short jobs keep arriving. This simulation demonstrates the dynamic nature of preemptive scheduling and how decisions change based on the shortest remaining time. Thank you for watching this simulation. I hope it gives you a better understanding of how SRTF scheduling algorithm works.
Round robin. So round robin is designed for fairness. It gives every process a fixed amount of CPU time called a time quantum, ensuring everyone gets a turn. So how does round-robin scheduling works? From the ready queue, the CPU will select a process. Then the CPU will determine whether the quantum time is bigger than the burst time. If the quantum time is bigger than the burst time, it will execute the process until complete. If the quantum time is lower than the burst time, it will execute for time quantum. When the time quantum expires, it will check whether the process is executed completely. If it does not complete execute, it will continue the process from the ready queue. If it already completed, the process will terminate.
Okay, hi. So this is the simulation of the round robin scheduler algorithm. As we know, round robin is a preemptive algorithm. So the process will be preempt or interrupt during the processor. So when the process will be interrupt at round robin, we know that it depends on the time quantum. Uh, so as this example, we can see I make the simulation. So we have the round robin simulation with a time quantum of 3. So meaning that the processor will process each of uh, the processor will execute each of the process. How long is 3 time quantum. So we have here P1, we have 10 uh, execution or CPU burst, 10 CPU burst. P2 we have 6, P3 we have 8, and P4 we have 4. So we will see how is the algorithm of the round robin scheduler algorithm when it will preempt. So as we know, it will preempt after the uh, 3 execution time, meaning that when it execute 3 cycle, so it will preempt to the next process. Okay, so if now we have the highlighted one at the P1. So P1 is being executed in the processor. So after the uh, 3 execution cycle, so it will preempt and switch to the next process, which is process 2. So here we can see the process 1 just now is 10. Now it show 7 because 3 of the execution time is already used, and the total of the execution time executed is show here. You can see P1 already execute 3. Next it will execute the process 2. Process 2 now left 3. So after this it will execute process 3. Then process 4. Then after done the process 4, it will go back to the process 1. So here we have the process 1 until process 4. The executed time here is show 333. So it will execute like normal. Okay, here we see the process 2 already finished because process 2 only have 6 execution time. So it will end. Then the process already finished here. Here shows 6. That process 3, process 4, 4 only have 1 left. So it will execute only 1. Then it will be interrupt. Then go back to the process 1. After process 1 done, process 3 and process 1 back. So all the process is completed. So here is the example of the round robin simulation I do. So we can see here. Okay, thank you.
Thank you, Shafiq, for the simulation. As we can see from the simulation, how the round robin works, the round robin guarantees responsiveness and prevents starvation. For example, if you have one piece of bread and you give it to everybody, is fair, and nobody will be starved. So it makes it ideal for interactive desktop environment. Meaning, if you have a desktop, it can run process simultaneously and utilize the CPU maximum. Therefore, it is the best. So in the real world application, we have the engine of modern desktop. Round robin is the backbone of interactive desktop OS like Windows, Mac OS, and Linux. It's why you can run a browser, a video, a word processor, and everything simultaneously, smooth and responsive without any delays.
In conclusion, shortest remaining time SRT and round robin each have their strengths. SRT is efficient and reduce wait time, while round robin make sure every process get fair CPU time. Our simulation project help us really understand how this algorithm behave, not just in theory but in real time. It also gives students a more engaging way to learn operating system scheduling.